So the next topic of conversation for probability is this concept of expected value, which many of you didn't quite get when we did the pre-test for this unit. I think what you're going to see when we get to the end of this unit, when that pre-test becomes our review, is you'll be like, wow, I know all this stuff now. So that's the goal in any class. So with expected value, we have this concept of predicting how much you might win or how much you might get when you play a game or when your grandfather comes over to visit and he always gives you a piece of advice and a bill from his wallet. That's example A that we have here. So when Nate goes to visit his grandfather gives him a piece of advice and a bill from his wallet. He closes his eyes and takes one bill out and gives it to him. So if it's a $1 bill, that's what Nate gets. If it's a $5 bill, that's what Nate happens to get. If it happens to be he's carrying around a Benji, you know what that is? A $100 bill, that's what he gets. So Nate's closing his eyes and saying, please be 100, please be 100. But here we go. On this visit, he sends Nate to get the wallet. Nate peeks inside and sees 8 bills. 2 $1 bills, 3 $5 bills, 2 $10 bills, and 1 $20 bill. So being the honest kid that Nate is, he doesn't just reach in and take the $20 bill. He gives his grandfather the wallet, and he's wondering, of course, like all good math students do, what the expected value of the bill Nate will receive. So what we need to do here with expected value is the formula goes like this. You take the sum of x times p of x. And that's not much of a formula. We really need to interpret that. What does that mean? So what the x and the p of x mean is as follows. Ready? The x is the value of each bill, or each item, whether you're playing a game or rolling dice or something like that. It's the value of each outcome, while p of x is the probability of each outcome. And what does the Greek sigma mean? Sum. So we need to multiply the value of, let's say, a $1 bill times the probability of him getting it, plus the value of a $5 bill times the probability of him getting that, plus the value of a $10 bill times the probability of that, and so on. That's how the formula works. So it's going to be like this. Something times something plus something times something plus how many different bills are in grandfather's wallet? 4. Well, how many different types of bills? 4. Something times something equals the expected value of this situation. So what's the value of a $1 bill? $1 times, what's the probability that he'll randomly select a $1 bill? Well, there are 2 of them out of 8 bills. Okay? Let's do 2 8s. Let's do all 8s to make it easy, okay, instead of simplifying. What's the value of the next size bill? 5. How many are there? 3 out of 8. This is all you need to do for expected value. Take the value times the probability plus the value times the probability, and so on. How much is a $10 bill worth? Yeah, $10. And we multiply that value times how many there are out of how many total bills there are. And finally, there's a 1 in 8 chance that he'll get a 20. Sorry, Nate, no Benjis. Or grants. You know what grants are? 50s. 50. Yeah. So, let's go ahead and calculate that and see what we get. What did you get? 7.625. That is a dollar amount. 7.625. Here's another name for expected value. They also call this average value. Will Nate actually get $7.62.5? No, the U.S. Mint doesn't produce a bill worth that much money. It would be weird if they did. That's the average that he'll get. He'll either actually get 20 or 10 or 5 or 1, but this is called the average or expected value in math. All right? So you can walk away from handing over the wallet by saying, I'm going to get an average of $7.63 out of this whole transaction. Right? That's my average. But you might just get $1. You might get $20 or something in between. Now, where expected value really comes into play, and we'll see that as we do more examples, is when you're going to run a game for, let's say, a fundraiser for the organization you're with. If you figure out the expected value of a prize or the tickets that you're going to sell, then you can calculate how much you want to sell the tickets for to figure out, in turn, how much profit you're going to get. So if we wanted to sell a raffle ticket and we know that the average prize will be $3 and we want to make so much money, we can figure out how much should we sell them for. If we know people are going to win on average $3 and we sell them for $5 and we sell 1,000 tickets, how much money are we going to profit? $2,000, right? The difference in what you sell them for, how much people are going to win off of them, and how many you're going to sell, times how many you're going to sell. So that's expected value sort of in a nutshell. Example A.